Good evening, class. We are looking at college algebra foundations or prerequisites. This is the second part to get us started with the course. We continue with performing addition, subtraction, and so on when it comes to rational expressions. In this case, adding and subtracting, reminding everybody when you add two fractions, you come up with the LCD. For example, A over B plus C over D would be AD plus BC over BD. And if you're subtracting, again, you have to come up with the LCD first. So having said that, we are going to add these two. In this case, remember, subtraction is a form of addition, or subtract makes no difference. The first thing is to factor each denominator. This one is clearly y times y minus 1. And this one, you notice there's a GCF of 2. And this is a perfect square trinomial according to this. It's y minus 1 quantity squared. So we factor each piece. Now, what is the LCD? So everything that we need here, we need number 2, we need y, and we need y minus 1. But y minus 1 here has exponent 1, here has exponent 2. We're going to go with exponent 2. I hope everybody is comfortable finding LCD. So one more time, we need every factor. So we need 2, we need y, and we need y minus 1. But you look at this one, you see has exponent 2. Therefore, this one, we have to raise it by simply multiplying by 2 times y minus 1. This one, we have to raise it. When you compare these two, you just are missing y, so times y over. So again, this is the factor is used here compared to this one. And this is the factor used compared to this one. So let me erase my word. Then you multiply these two, you foil it, and you keep the 2 out, which means this one times this one is y, then 2 and negative 1, they add up to positive 1 times y, and then minus 2. This is simply negative 3y squared. Distribute the 2, we get 2y squared plus 2y minus 4, and then minus 3y squared. And we keep the common denominator. These two combine into negative y squared. So the final answer would be negative y squared plus 2y minus 4 over 2y times y minus 1 quantity squared as the final answer, everybody. And so we are going to move on. We want to simplify a complex fraction. Remember, a complex fraction is a fraction within a fraction. So what is the best course of action to simplify a complex fraction? You find the LCD for all fractions. You have 1, 2, 3, 4 fractions for all 4 fractions. Notice for the numerator is a times a plus 1, and it repeats. For the denominator, simply the product of these two is the LCD for the top as well as the bottom. So you're going to multiply by that. And bear in mind, this expression equals 1. So you multiply the top and the bottom by it. So We're going to multiply each one by it. I'm going to show you with a couple of steps. Normally I skip that, but that means multiply this one by that, this one by it, so on and so forth. So when we do that, what happens? In this case, a plus 1 cancel out and it becomes a squared. In this case, a cancels out and it becomes plus 1 times a plus 1. Again, the same thing here. A and a cancel out. In this case, a plus 1 cancels out. So as I mentioned, this is a squared. This is plus the parentheses a plus 1. This is the parentheses a plus 1 only, and this is a. Therefore, the numerator is a squared plus a plus 1, and the denominator, these two combine into 2a, so we get a squared plus a plus 1 over 2a plus 1. And of course, you should always ask yourself, can I simplify this further? Because any fraction must be put in its lowest term, and the answer is no, because this is a prime polynomial. If this was 2, then it could be factored out. This cannot be factored out, and we are done. So a quick recap. If you have a complex fraction, that means a fraction within a fraction, the best course of action is to multiply the top and the bottom by LCD, the least common denominator of all fractions. Negative exponent, if a is a non-zero real number and n is any integer, a to the power of minus n is 1 over a to the power of n. These are various, exponential forms discussed. So if you have 2 over 5 to the power of negative 3, the best course of action is to go with this. That means flip it over. 5 halves to the power of positive 3. Okay, so we are looking at this one, everybody. And 5 cubed is 125, 2 cubed is 8, and that is the final answer. Rational exponent for all integers m, all positive integers n, and all real numbers a, for which a to the power of 1 over n is a real number. We have nth root of a is a to the power of 1 over n. So to do this, we're going to remind you also a to the power of m over n is a to the power of 1 over n to the power of m. By the way, in the radical format, you can write this as a to the power of m, or the nth root of a to the power of m. So you could rewrite this as 125 to the power of 1/3 squared, and this one is cube root of 125, 5. So 5 squared is 25. 27 to the power of 1/3 times 27 to the power of 5/3 over 27 to the power of 3. We have the same base, 27 in each case. So the top one, we use the product rule and we add these two. 1/3 and 5/3 adds up to 6/3 or 2. And now we use the quotient rule. 2 minus 3, 27 to the power of negative 1 is 1 over 27. Fourth root of 16, or 16 to the power of 1/4, You should know the answer is 2, but one way to look at it, remember 16 is 2 to the power of 4. These two cancel each other and they give us 1. Again, we should know this one, but in case. The fifth root of negative 2, you should recognize this as negative 2 to the power of 5. Remember, when you have an odd index, this is called the index, then underneath can be negative and negative comes out as negative. But if you have even, it's a different story. So just for the sake of argument, square root of 4 is 2, but square root of minus 4 is 2i, okay? Cube root of 8 is 2. Cube root of minus 8 is minus 2. So when the index is odd, there is no restriction. So this is negative 2 to the power of 5. So these two cancel each other. They give us 1. And the answer is negative 2. That's one way to look at this. As I mentioned, a to the power of m over n has 3 different formats. So we've been looking at basic one and now a more interesting one. So the best approach then, a to the power of 2/3, we would write this in radical format, becomes cube root of 8 to the second power. And that, you know, it's cube root is 8, cube root of 8 is 2, therefore 2 squared, which is 4. Negative 32 to the power of 4 over 5, we do the same thing. It's the fifth root of square root of negative 32 to the fourth power. In other words, we are using this one. And we've already discussed that this is negative 2. And so to the power of 4 is positive 16. Remember, when you raise a negative number to an even number, it becomes positive. Because you multiply negative 2 by itself 4 times, it ends up being positive. So the nth root of a to the power. If n is an even positive integer, then the nth root of square root of a to the power n is absolute value of a. And if it's odd, if n is an odd positive integer, the nth root of a to the power of n is a. In other words, if we are looking at this example, the fourth root of square root of p to the power 4, we don't know whether p is positive or not. It comes out as absolute value of p. Because even if p is negative and you raise it to the power of 4, becomes positive. So it has to come out as positive, but in case it's negative. In other words, just to give you an example of that. So if I said, what is the fourth root of 2 to the power of 4? It's 2. What is the fourth root of negative 2 to the power of 4? You say absolute value of negative 2, which is 2. That's what we are saying. Because by using the order of operation, first you do this one and change it to 16. Now you take the fourth root and you get 2. That's the reason. I hope everybody's comfortable with the concept. What about here? You notice you want to take a root, and 16 is 4 squared. M to the power of 8. 8 is divisible by 2, so is 6. In other words, you have 4 m to the power of 4 r cubed quantity squared. So it comes out. But m and r are variables. If the answer was 4, you would just bring the 4 out. But you can't do that. Now, if you left it as that, it's fine. However, 4 can come out. M to the power of 4 can come out. Both of them, they can come out of the absolute value sign. Why? 4 is a number as in positive, or just square the absolute value of 4 is 4. M to the power of 4 because the exponent is even, it's positive, but you have to keep the R cubed. So you can rewrite it in this format. Okay. Why are you keeping that in the absolute value? Because you don't know if R is positive or negative. And when it's raised to the power of an odd number, the sign, if it's negative, remains. Okay. Now, what about this one? Now, they cancel each other, but it's not the negative 2 that comes out, but rather the absolute value. Why? You can raise it to the power of 6 first if you want. And it becomes, by the way, this if you raise it to the power of 6 is 64. So the sixth root is positive 2, and that's why you want to distinguish between the two. So to recap, if you're dealing with a variable and you don't know the variable is positive or negative, you follow it in the manner that is discussed here. Unless they say, we know the variable is positive, therefore we don't need it here or we don't need it here, okay? The number is very straightforward. For real numbers a and b and positive integers m and n, for which the indicated roots are real numbers. The nth root of a times nth root of b, you can say nth root of ab. If it's a over b, you can take it out. And of course, this case, b can't be a 0. And if it's the mth root of the nth root of a, you can put the index m times n and take a root. That's the meaning of it. So what is 6 times 54? You can multiply. Okay. And we get 324, which gives you 18. By the way, just in case, there is a methodology to come up with the answer just by looking at it. 6 is 2 times 3, 54. 54, you write it in a factored format, okay? So let me just show you prime numbers. Prime numbers. 2, 3, 5, 7, 11, 13, 17, 19, 23, so on and so forth. So number 54, can you divide it by 2? Yes, you should do. Then 27, can you divide by 2 anymore? No. 3, 9, 3, 3, 3, 1. When you hit 1, you're done. So this one is times 2 times 3. There are 3 of them cubed. So what you're dealing with here is 2 squared times 3 to the power of. So if you want to take a root of that, this comes out as 2. This comes out as 3 squared. 2 times 3 squared, 2 times 9 equals 8. Okay? So the factoring will help you come up with the answer in this manner. I'm going to move on to the next question. So I'm going to erase my work. And then m and m squared is m cubed. Okay. And it comes out as m. Do we have to worry about the absolute value? No. Why not? When the index is odd, whatever m might be, positive, positive comes out, negative, negative comes out. What about this one? How do you simplify? You separate the top from the bottom, and the bottom comes out as 8, and you're done. So pretty straightforward, everybody. Okay. We are going to move on. All right, square root of 175, we want to come up with the answer. And the idea is that because you want to take the square root, you find the largest uh, perfect square number, which is a factor of 175, that's 25. 25 is separated, comes out as 5. Now, if you can't see that, everybody, you have to factor it. And I'm going to show you actually here 175. Can you divide by 2? No. Can you divide by 3? 1 plus 7, 8, and 5, 13. No. A number is divisible by 3 if the sum is divisible by that, but clearly we can divide, it's divisible by 5. So you divide it, and you get 35, and 5, you get 7. So what you can write here, you can write 5 squared times 7, and then 5 squared comes. That's one way to do. Now, what about part B? I'll show you what you see it in most texts, and I'll show you how I deal with that, okay, in a moment. So because this is a cube root, you find the biggest number you can come up with, which has the exponent 3. In other words, the cube root can come out. 81 is the product of 27 and 3. So this one is 27 and 3. This one is x cubed times x squared. This is y to the power of 6 times y, and this is simply itself because 6 is divisible by 3. So you keep this one, and this one separate, and they remain inside. The radical sign. Okay, everybody. And whatever you can take out, you will take out. So what can you take out? 27 cube root comes out as 3. X cubed cube root comes out as x. Y to the power of 6. Y squared, z squared. And you keep the rest of it. And that's the idea. So it's very straightforward, everybody. I hope everybody's fine with that. But let me show you what I do, because if this thing gets more complicated, it makes it easier, the method that I'm going to look at. So here's the way I would do that. Let me erase my board first. So for number 81, but I'm going to factor it. I hope you know 81 is 3 to the power of 4. Okay. So I'm going to replace that with 3 to the power of. Okay, so let me actually rewrite it here. 3 to the power of 4, x to the power of 5, y to the power of 7, z to the power of 6, and we want the cube root. Okay. Now, I will pick the exponent for each case and divide by the index. So when I divide 4 by 3 gives me 1 with the remainder 1. So the answer is 3 to the power of 1 out, 3 to the power of 1 in. Then I'm going to divide 5 by 3, and I get 1 remainder 2. So x to the power of 1 outside, x to the power of 2 inside. Then number 7, 7 divided by 3 is 2, remainder 1. So y to the power of 3 out, y to the power of 1 in, and finally, let me use a different color, this one. 6 divided by 3 is 2, so z squared out, and there is no remainder. And I hope you see, and then I'm gonna rewrite it. It becomes exactly what we have here. Now, the more complicated this expression, the easier this way. So a quick recap of the method I just mentioned. I would write each one in factored format. Everything is in factored format except 81. I write it as 3 to the power of 4. And I'm going to divide this, all these exponents, by 3. The quotient comes out, the remainder remains inside. Okay? And if any of them is smaller than that, you just don't touch it. Okay? Because if it's smaller than the index, it simply remains. So pretty straightforward, everybody. All right. Add or subtract as indicated, assume all variables represents positive real numbers. So you don't have to worry about anything. That's the idea. So in order to combine radicals, just like polynomials, you can only add like radicals. That means the radical part must be identical. So for example, here the radical part is 2, square root of 2. Here's is different, here's is different. So you can't add them up just the way they are. However, 18, we should, I mean, you don't have to really factor it. You should recognize it's 9 times 2 and 72 is 36 times 2. So we should recognize that. So 9 comes out as 3. So remember, they're all being multiplied. And 36 comes out as 6. So this one remains. 9 comes out as 3. With this one becomes negative 24 square root of 2. 36 comes out as 6. With this one becomes plus 24 square root of 2. And so what you need to notice is that this part is identical. All you need add their coefficients. 7 minus 24 plus 24 is simply 7, and you're done. That's how you add them up. All right, let's see. This one again, you can do the factoring, but you may recognize this as 49 times 2. Sometimes it's easier to see the bigger picture, okay? And if you do see it, you're done practically. 98 is 49 times 2. X cubed 3 divided by 2 is 1, remainder 1, or just write it as x squared times x. This is a done deal. 32 is 16 times 2. So if you write it in this fashion, here's what happens. 49 comes out as 7. X squared comes out as 7. 16 comes out as 4. What about the rest of it? Notice what's in there. What remains is 2xy, in this case, the same thing. So you have 7x squared of 2xy, 3x times 4, 12x. square root of 2xy. So again, notice now this part and this part, they are identical. So you're adding 7 of this to 12 of that. That's 19 total. 19x square root of 2xy. So I can't emphasize this enough. This is the way you would come up with the answer. It's very straightforward, everybody. We're going to move on. All right. Square root of 2 plus 3 times square root of 8 minus 5, you basically FOIL. Okay. And so we're going to multiply these two. We get square root of 2 times square root of 8. These two, square root of 2 times 5. These two, 3 times square root of 8. These two, 3 times negative 5. So when you multiply these two, you get square root of 16. This is minus 5 square root of 2. This is plus 3 square root of 8. Now, square root of 8, everybody, square root of 8 equals 4 times 2, 2 square root of 2. Okay? So square root of 8 is that. So I hope everybody's okay with that. This is important to notice. So that's why you can combine them. Otherwise, you can't. So how do we combine it? This is 4. This doesn't change. This becomes 6 square root of 2. This doesn't change. 4 and negative 15, they add up to negative 11. Minus 5 of that, positive 6 of that, these two add up to positive 1. So positive 1 square root of 2, or simply 1 square root of 2, or just square root of 2. You don't have to write the 1 here. Okay. So that's pretty straightforward, everybody. All right, let me erase my book, everybody. Well, I can do the foiling. Or recall, a squared minus b squared is a minus b, a plus b. So you're looking at a minus b times a plus b, where a is square root of 7. So square root of 7 squared minus square root of 10 squared. So knowing the identities will speed up the process. The answer is 7 minus 10, which is obviously negative 3. Rationalizing. If they say rationalize or divide or simplify, it means the same thing. I can't have a square root at the bottom. So to rationalize it, we have to multiply by this one itself to take it out. Therefore, we multiply by square root of 3 over square root of 3 because this fraction equals 1, and therefore this action is justified. So the denominator is simply 3. The numerator is 4 square root of 3 over 3. Two over cube root of x. Of course, x can't be 0. It's important to know the index is 3 here versus the index was 2 here. That's why square root of 3. So if I multiply by cube root of x, nothing happens. Rather, if I want this one to come out, somehow it comes out if I have x cubed. These two must be identical. So if these two must be identical, then remember this one doesn't have an exponent, which means if I were to write it, the exponent is 1. So in order for it to come out, it can't be multiplied by square root of cube root of x, but rather by cube root of x squared. And that's the key you need to remember. Okay? Because cube root of x times cube root of x squared is cube root of x cubed, which is x. So that's what we do. We multiply and divide by cube root of x squared. When we do that, the denominator comes out as x. The numerator, you just write them as a product. So these two become cube root of x cubed, come out as x. And these two, you just write. What happens when the denominator involves a radical format, but in essence you have two terms? You call it a binomial in essence, so you multiply by its conjugate. The conjugate for this expression, remember, the conjugate for a minus b is a plus b. The conjugate for a plus b is a minus b. So 1 minus square root of 2. Conjugate is 1 plus square root of 2. And you have to put the same thing at top because this expression must be equal to 1, otherwise it's not acceptable. So we're going to multiply. Of course, the top is simply 1 plus square root of 2 because times 1 doesn't change. And this one, we're going to go with a squared minus b squared. 1 squared is 1 minus square root of 2 squared comes out. So the product of these two, everybody, is 1 squared minus square root of 2 squared. So the bottom is 1 minus 2, which makes it negative 1. So if you're dividing by negative 1, everything in the numerator changes sign. So it becomes minus 1 minus square root of 2. That's what we get as the final answer. So in order to rationalize denominators, okay, or simplify, you can't have a radical format in the denominator. In this case, you multiply by itself, and of course, this fraction must be 1, so multiply by square root of 3 over 3. But this one, because the index is 3, and it comes out if the exponent is 3, and this one has exponent 1, you need x squared. So for example, just to make sure we understand, if the denominator somewhere, it's let's say the fifth root of x, then what do you need? You need the fifth root of x to the power of 4. So it becomes the fifth root of x to the power of 5 or x. So The sum of the exponents must equal to the index for it to come out. And if you have two numbers here, or one of them may even be a variable. For example, if this was x, doesn't matter, x minus square root of 2, you multiply times x plus square root of 2 in order to use this identity and take them out.